the awesome tutor, and today we're going to be looking at geometric series and sequences. A geometric series is, so you have one term, to get to the next term, you multiply by a common ratio. And to get to the next term after that, you multiply by that same ratio. Then you multiply by that number again, and again, and again, and again. That's how you get from one term to the next. So here, this is a geometric series, because it has a common ratio, which is 2. To get from 2 to 4, you multiply by 2, then you multiply by 2 again, then you keep multiplying by 2. 2 is the common ratio. This is also a geometric series because it has a common ratio, 1/4. To get from 100 to 25, you multiply by a quarter, then you multiply by a quarter again, and again, and again, and again. This is not geometric. It does not have a common ratio. It's actually arithmetic with a common difference of -5. This is not geometric because it does not have a common ratio. To get from 26 to 3.25, you multiply by 1/8. To get from 3.25 to 0.8125, you multiply by 1/4. So the ratios are not common. It does not have a common ratio, therefore it is not geometric. It is not a series. Okay? Next. Okay, let's talk about the nth term. To find the nth term of a geometric sequence, we use AR to the n minus 1. Okay, so here's our first term, A. Alright, to get from the first term to the next term, we multiply by the common ratio, so AR. Then we multiply by the common ratio again, so A times R, so AR squared. Then we multiply by the common ratio again, and again, and again, and again. We see that the index of R, so if you like it, this could be AR to the 1 and AR power of 0, is always 1 less than the position in the series. So the first term, the number 1, and the index of R is 0. 0 is 1 less than 1. Let's look at the third term, so number 3. The index of R is 2, so it's squared. So 2 is 1 less than 3, and that is what this is trying to say. So that's where we get the n minus 1 part, AR to the power of n minus 1. Where A is the first term, R is the common ratio, and n is the nth term. Okay? And if you want to find the common ratio, an easy way to do it is to divide one term by the previous term. So if we divide the second term by the first term, it's going to give us the common ratio. If we divide the fourth term by the previous term, which is AR squared, we're going to get the common ratio. Alright? If in the exam they give you, say, only the second and the fourth, so it's not one term and its previous term, then if you divide them, it is going to give you the common ratio squared. So to find the actual common ratio, you have to square it. But then it could be the positive or negative square root. So they'll probably tell you R must be bigger than 1 in the exam or something like that to narrow it down. Anyway, alright, so here's a geometric sequence. I want you to give me the 10th term. Pause the video, have a go. Okay, so we know that A is 3. To find the common ratio, we just divide one term by the previous term, so it's 2, R is 2. If you could not spot that already, it's fairly obvious. And you just use the formula AR to the n minus 1. You want the 10th term, so n is going to be 10. So let's just stick the numbers to the formula. 3 multiplied by 2 to the power of 9. 10 minus 1. You put that into your calculator, you're going to get 1,536. That is the value of the 10th term. Right, so now you know how to use the formula. Let's move on. So, the sum of a geometric series. We can use the formula A multiplied by R to the n minus 1 over R minus 1, or A multiplied by 1 minus R to the n over 1 minus R. Now, in your exam, you might be asked to prove this formula, or the formula for the sum of an arithmetic series. So, if we write the sum in full, A plus AR plus AR squared plus AR cubed, all the way to the last term, and we multiply that by R, we're going to get this. What if, like in simultaneous equations, we take one away from the other? We're going to be left with A take away AR to the n, because all of these just cancel out. And we're left with a and ar to the n. Then we just factorize and rearrange, and we get s of n is equal to a multiplied by 1 minus r to the n over 1 minus r. To get to this formula, you just mess around with negatives when you're factorizing here, and you'll get it. Now, when the common ratio is smaller than 1, I would use this formula. When it's bigger than 1, I would use this formula. Because then you're not number crunching with negatives, which is never good. So here's part of an exam question, so you can practice using the sum formula. Alright, the business makes a yearly profit of £275,000 for the year 2016. The profit is expected to increase by 10% each year. The question is, find the total expected profits for 2016 to 2026 inclusive, giving your answer to the nearest £100. Pause the video, have a go, then I'll go through it. Okay, so here we have to use the sum formula for a geometric series, alright, because it's the total expected profits. So A is 275,000, that's the first term, 2016. R is going to be a 10% increase, so convert that to a decimal or a fraction, 1.1, or if you used 11 over 10. N is going to be 11, okay, that's the number of years. Okay, 2026 minus 2016 gives you 10, but it's inclusive, so it's 11. Alright, you just put all the values into the formula, and you get this not nice number. Okay, and remember, to the nearest £100, so you just round it. And that's your answer. £5,096,100. Easy. By the way, it's only 3 marks. Okay? Usually when they ask you to use a formula, it's not going to be worth that many marks because you're just putting numbers into a formula. Okay, alright, now for geometric series, there is another formula, but for the sum to infinity. So not the sum to n terms, it's the sum to infinity, and that is a over 1 minus r. This only applies for geometric series which are convergent, and they're only going to be convergent when the common ratio is smaller than 1 or bigger than negative 1. Okay, now consider this geometric series. The common ratio is a half. The further we go on, so the higher the value of n, the higher the term, the position in the series, the smaller the value we're adding on to find the term. So the value we're adding on gets smaller and smaller and smaller and smaller until it becomes basically nothing. We want to find that as we add less and less and less and less and less and less, where the series converges, where the sum to infinity is. Alright? You add less and less and less and less, and it's going to converge to one number. Okay? And that number is going to be the sum to infinity. It never reaches that number, alright, like an asymptote, but it converges towards it. So, here is the normal formula for the sum to n terms. If r is smaller than 1 or bigger than negative 1, then as we increase the number of terms, alright, r is going to tend to 0. Alright, so we have a half. Alright, we end with power of n minus 1, the first term is 3. The further we go into the series, the higher n is going to be. Alright? And we all agree that if the power of a fraction gets higher and higher and higher, then the actual value of the fraction is going to get smaller and smaller and smaller and smaller and smaller. And then you can basically consider it to be 0. It gets so small, it might as well be 0. So as n tends to infinity, as n goes higher and higher and higher to infinity, the value of the fraction, the value of r, might as well be 0. So, the sum to infinity, a 1 minus r to the n, so might as well be 0. A times 1 minus 0, so a times 1. You get a over 1 minus r. So the sum to infinity for this series is going to be 3 over 1 minus a half. So it's going to be 6. As you add more and more terms, so as you add less and less and less and less, it's going to converge to 6. Never reaches it, but gets closer to it. Alright, so you're going to end up with like 5.999999999 something. Okay, alright, now that we've gone through everything important in geometric series, I'm going to give you an actual exam question and I want you to do it, and then I'll go through it with you afterwards. So the wheat is to be grown on a farm. A model predicts that the mass of wheat harvested on the farm will increase by 1.5% per year, so that the mass of wheat harvested each year forms a geometric sequence. Given that the mass of wheat harvested during year 1 is 6,000 tons, show that, according to the model, the mass of wheat harvested on the farm during year 4 will be approximately 6,274 tons. So I showed that question. Alright, pause the video, have a go, then I'll go through it. Alright, so we know that A is 6,000 tons, right? That was year 1. We know that the common ratio is a 1.5% increase, so it's 1.015. And I want you to find mass wheat harvested in year 4, so n is going to be 4. We just use the formula AR to the n minus 1, because we're going to find the value of a term in the sequence, alright, the fourth term. So we put these numbers into the equation. That was 1.015 to the power of 4 minus 1, so cubed. Put that into your calculator. You get 6,274.07 blah 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 blah. Round it to the nearest whole number, and then you have shown that it is approximately 6,274 tons. Alright, next part of the question. During year n, according to the model, there is predicted to be more than 8,000 tons of wheat harvested on the farm. Find the smallest possible value of n. Right, pause the video, have a go, and then I'll go through it. Okay, we know what A is, it's 6,000. We know what R is, it's 1.015. We need to find the value of n that gives us 8,000. Alright, or more than 8,000. So AR to the n minus 1. So 6,000 multiplied by 1.015 to the power of n minus 1 is going to give us 8,000. We have to solve this equation for n. Now, using the law of indices, I would separate this into 1.015 to the power of n multiplied by 1.015 to the power of minus 1. Alright, so 1.015 to the power of n is going to be equal to 8,000 divided by 6,000 times 1.015 to the power of minus 1. The way I would do it now is use logarithms. Alright? You can do it a different way, but for me, I think it's easier to use logarithms because my calculator, you can change the base. So, what power do you have to give 1.015 to give you whatever that is? And that should give you n. Right? So I'm going to use the calculator now and find the answer. Okay, so logarithm base 1.015 and 203 over 150, that's going to give you 20.322 blah 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 blah. The smallest possible value of n that gives you more than 8,000 tons. So if we use 20, it would give you less, because this value does give you 8,000 tons. Alright, so if we use 20, it's going to give us less, so you have to use the next possible number, which is 21, which is going to give you more than 8,000 tons. That was 5 marks. Again, if you don't use logarithms, you can find a different way. I don't care, as long as you get the answer. And if your calculator does not use different bases, like mine actually does, then you're going to have to change the base. So, tough for you. Get a better calculator. Okay, it costs £5 per ton to harvest the wheat. Assuming the model, find the total amount that it would cost to harvest the wheat from year 1 to year 10 inclusive. Give your answer to the nearest £1,000. Okay. Pause video, have a go, and then I'll go through it. Okay, we know what A is, we know what R is, we know what N is, it's going to be 10. We just use the sum formula for a geometric series, and we put in the values. Alright, so 6,000 multiplied by 1.015 to the power of 10, take away 1, over 1.015, take away 1. Alright, you put that into your calculator, you're gonna get this number. It says to the nearest 1,000, so your answer is gonna be 64,000 pounds. No, sorry. It says to find the total cost. We found the total harvested. Okay, now the total cost. Total cost is £5 per ton, so we just multiplied that. We multiplied this number by 5. Alright? And then we round that to the nearest 1,000. So our answer is 321,000 pounds. Alright? That was 3 marks. This has been the Awesome Tutor. Bye.